So we're continuing Module 5, and today we're going to talk about different types of probabilities: marginal, joint, and conditional probabilities from two-way tables. Last week we talked about two-way tables, which is related to categorical variables and relation between categorical variables. Introduction. In the previous lesson, we constructed a two-way table to represent the relationship between two categorical variables. This lesson introduces three types of probabilities that can be determined from two-way tables. One of them is marginal, the other one is joint, and finally we have conditional probability. Let's take a look at one example, then we go over the definitions. U.S. Census data. The United States Census Bureau collects large amounts of data about the population of the United States. The two-way table below contains 2010 census data showing marital status by sex for people over the age of 18 living in the United States. So numbers in this table are in millions of people. So 32.4 means...
She's really loud.
I'm sorry about that.
I have to turn your volume up.
So numbers in this table are in millions of people. So 32.4 means 400,000. So you have 32,400,000. Each number is rounded to the nearest 0.1 million, which is 100,000. Well, let us take a look at our table here. We have a two-way table. On the left-hand side, on the left column, on the first column, we have the marital status: never married, married, divorced, widowed, and also you have the total. So sex is divided into two categories, male and female. So for male, never married, you have 32.7, married, 64.4, divorced, 10, widowed, 3. All of these are falling into the male category. For female category, never married, 27.8, married, 65.1, divorced, 13.7, widowed, 11.4. There are the following questions. Question says, use the two-way table to answer the following questions. First of all, what proportion of the adult population in the US is male? And 2, what proportion of the adult US population is currently married? So let us go to the board, write these down, then analyze the data that we have. So the information given to us for Module 5, Part 2 are as follows. So here you have sex, which is divided into two categories, male and female. Then we have marital status, which is divided into never married, married, divorced, and widowed. And eventually we have the total for each of these categories. take a look at the numbers here. 33.7 million. Female, 27.8. 64.4. We have 65.1. 10. 11.4. So let me see, this is 3, so this is 13.7, 13.7, this is 3, 11.4, and here we have the total, which is 111.1 and 118, and very well, the total, so let me write total here with T, so you know that we're talking about the total here. So the total number of male and females that never married is 61.5. The total number of males and females married is 129.5. Then divorced is 23.7. And widowed, we get 14.4. And finally, the total number of people participated in this census is 229.1 million. So this is your total. Again, note that you have first category for male, second category for female, and also you can categorize this based on marital status. So let's take a look at the questions. The first question says, what proportion of adult population in the US is male? What proportion is male? And the second one says, what proportion of US population is currently married? What proportion is married? So to answer these two questions, when it comes to proportions, we have to construct a fraction. So we have something on the numerator, we have something on the denominator. So the proportion you have something on the numerator. So what is on the numerator? We're looking at male category. How many male do you have in the United States? 111.1 out of the total population, which is 229.1. The proportion of male. Let us do the calculation to get an approximation. What percentage do you have? So we have to flip them. Very good. The smaller number goes on the numerator. The larger number, which is the total, goes on the denominator, the total. Let's do the calculation. What do you have? Very well, excellent. Approximately, thank you, Marco, approximately 48%. Almost 48%. So less than half of the population includes male. So second question says, what proportion is married? What proportion of US adults above 18 are married? Okay, we need to look at the married category. The married category includes both male and female is 129.5. So the proportion of married, which includes married males and married females, is 129.5. Out of the total population, which includes 229.1 out of the total. So what do we get approximately? How many percent? What's the percentage? Approximately we get, very good, thank you, Josia. 57%, perfect. Almost 57% are married. So these are the information that we derive by looking at different categories. We can answer these questions as well. What is the proportion of females in the United States? We can answer this question. What is the proportion of never married adults in the United States? The proportion of divorced adults in the United States. You can answer the proportion of widowed adults in the United States. You can also combine these categories and see the connection between different categories. The proportion of males who are married, the proportion of females who are divorced, the proportion of males never married. So this is our goal. Our goal is to combine different categories and find the proportion and eventually take a look at the probabilities. Remember that when we are forming probabilities, the easiest way is to use the proportion, form the fraction, then convert that into percentage and try to analyze it. Next page. You need to know. We calculated the previous two proportions using only numbers in the margins or edges of the two-way table. These probabilities are called marginal proportions. The data indicates that 56.5 or almost 57% of adults in the United States are married. If we choose one adult at random from the US population, what is the probability that this adult is married? The probability that a randomly selected adult in the United States is married is equal to the proportion of adults in the United States who are married. So probability and proportion, you can assume they are conveying the same concept, the same meaning. This probability is an example of marginal probability. Again, we calculated the previous two proportions using only numbers in the margins or edges of the two-way table. These probabilities are called marginal probabilities. Marginal probabilities are calculated using only the totals in the margins of a two-way table. A common practice is to use P representing probability. So the probability that a randomly selected adult is in the United States is married can be written as P of married. So the probability of the event that a randomly selected person is married is equivalent to finding the proportion of married adults in the United States. This way of writing the probability is called the probability notation. Well, let's answer these questions. Use the two-way table to find the following marginal probabilities, or in another word, finding the proportions. If we choose one adult in the United States at random, find the probability that that person is widowed. 5. If we choose one adult in the United States at random, find the probability that that person is female. So we want to answer these two questions. The probability that a person is randomly selected and that person is widowed. And question 4, it says, what's the probability that randomly selected person is female? So P of widowed, and 4, the probability that they have a female. So again, finding the probability is equivalent to finding the proportion. The probability of a randomly selected person is widowed is equivalent, saying that what is the proportion of widowed in the United States using the table. So how many widowed do we have? Male 3, female 11.4 million, and the sum is 14.4 million. So 14.4 out of how many? The total is 229.1. Approximately we get, what's your calculation? %, very good, thank you. Almost 6%. 0.06 or 6%. 6% of the adult populations in the United States are widowed. What's the probability that you randomly select a person and that person is a female? This is equivalent, saying that what is the proportion of females in the United States? How many females do we have in total? 118 divided by out of the total, which is 229.1, which is approximately 4 and 5. Let's correct these numbers, match the note. 5, very good, 50%, very good, 50%, 51%, perfect, approximately 0.51 or 51%. So finding the probability, meaning that we have to use the proportion. Thank you, Anna, thank you, Marco. Okay, let's get back to the notes. Question 6. What's the probability that a randomly selected adult is male and has never been married? So here you have two conditions, is male and never been married. We write it this way. The probability that you have a male who is not married. And 7, if an adult in the United States is chosen at random, find the probability that that person is female and married. So as I mentioned before, now we are interested in combining different categories. And 8, if an adult in the United States is chosen at random, find the probability that person is male and divorced. Let's go to the board, solve this question. So question 6 says, male and married, the probability that the randomly selected person is male and married. Question 7 says, female and married, what's the probability that you have a female and that female is married? Yeah, and then let's see. We never married, okay. This is never married, the second one is married, and finally you have the probability of a male and divorced. That you have a male and divorced. Okay, perfect. So again, when we're talking about probabilities, we're talking about proportions. The probability of a randomly selected person is male and never married. So you have male, it means that we're looking at the column related to category male, and never married. Never married, it means that you're looking at this row. The intersection between this column and this row is 33.7. So 33.7 goes on the numerator. What goes on the denominator? What would be your denominator? The denominator is, we're looking at the total. So it is 229.1. Approximately is equal to 14.7%. Perfect. So let's move on to question 7. Now question 7 is asking, what is the probability that your randomly selected person is female and is married? So we're not working with this column anymore. We're working with female column. So female, look at this female column, and married. And married, it means that you're looking at the category or row related to married. The intersection is 65.1. So 65.1 goes on the numerator out of your randomly selected a person, so it's out of 229.1. Let's do the calculation. It gives us 28.4%. And finally, question 8 says, what's the probability that you have a male and divorced? Okay, you randomly selected one person. What is that probability? That that person is male. So we have to get back to previous column, male column. And we're looking at the category that that person is divorced. Category of divorced is this category. So the intersection is 10. We get 10 out of, the total is 229.1, which gives us approximately 4.4%. Let us continue. Next steps. Marginal probabilities and joint probabilities show us the likelihood that a randomly selected adult in the US is a particular category or in a combination of categories. These probabilities provide valuable information. However, they don't allow us to determine if there is a relationship between the categories. In this case, they don't help us figure out if there is a relationship between sex and marital status. Suppose we want to know whether the likelihood that a person is widowed is related to his or her sex. To answer this type of question, we need to find conditional probabilities, one of the most important probabilities in statistics, conditional probabilities. Let's explore what conditional probability can tell us about the relationship between the sex of an adult in the US and the probability that he or she is widowed. Question 9. We will first find the probability that a randomly selected female is widowed. We're starting with the fact that the adult chosen is female. So how many females are in the population? We need to know this information. How many of the females are widowed? What proportion of female adults is widowed? And finally, what's the probability that a randomly selected female is widowed? So let us go to the board, answer these questions. So 9. How many females do we have? How many females? Okay, so let's just erase these colors, the green ones. How many females? The total number of females in the population is 1. Perfect. How many females do we have in total? 118. How many females are widowed? So widowed and females 11.4. And what proportion of females adult that are widowed is going to be 11.4 divided by 118. Okay, just do the calculation. We get almost 0.097. So, which is almost the best case scenario, it is 10%. This is an example of conditional probability. Conditional probability. We denote it this way. We say that, hey, the probability of widowed given female, widowed given male, or a female given widowed, or so these are the things that you learn in conditional probability, and you write it this way. The first event, depending on or given, so we use a vertical line, given the second event. So in this case, let's see. So in this case, you have widowed given that they are female. So this is the probability of widowed given that you already know that you are focusing on female category. Given that that person is already, you know that it's coming from the female category. So this is a conditional probability.